Students, in the previous topic we studied electric field intensity due to a uniformly charged spherical cell. Spherical cell अंदर से खोखली होती है, सिर्फ बाहर उसके ऊपर मेटल होती है, अंदर से खोखली होती है. अब हमारा अगला टॉपिक है इलेक्ट्रिक फील्ड इंटेंसिटी ड्यू टू ए नॉन कंडक्टिंग चार्ज्ड सॉलिड स्फीयर. अब ये सॉलिड स्फीयर है, नॉन कंडक्टिंग सॉलिड स्फीयर है, मतलब अंदर से सॉलिड है. Let us suppose we have a non-conducting sphere of radius, we have a non-conducting solid sphere of radius r with center O, and this has a uniform volume density of charge rho. We have to calculate electric field intensity at a point P such that OP is equal to R, Therefore, with O as center and R as radius, consider a sphere S which act as Gaussian surface. At every point of S, electric field intensity E is same and directed radially outward. If Q dash is charge enclosed inside the surface S, if Q dash is charge enclosed by the surface S, then according to Gauss law, E dot ds integral over the closed surface, this will be Q dash upon epsilon, where epsilon is absolute electrical permittivity. Epsilon is absolute electrical permittivity of the material of sphere. Now when we solve this E dot ds, this will be E dot n cap ds, this will be Q dash upon epsilon. When we solve this, this will be E ds is equal to Q dash upon epsilon. E bar आ जाएगा क्योंकि electric field intensity at every point on the surface of sphere S is same. E ds, this will be Q dash upon epsilon. Surface ds integral over the closed surface, this is the total surface area of the sphere S, this will be 4 pi r square is equal to Q dash upon epsilon. Therefore E will be Q dash upon 4 pi epsilon r square. This is the electric field intensity at a point inside the non-conducting solid sphere at a distance r from the center. Now we can also write this as total charge inside the sphere S, this will be Q dash is equal to, this is volume of sphere S into volume density of charge. Volume of the sphere S is 4 upon 3 pi r cube and volume density of charge is rho, therefore Q dash is this. Therefore as E is equal to, हमने कैलकुलेट करा था, E is equal to Q dash upon 4 pi epsilon r square. Q dash की वैल्यू ये रखने पर Q dash की वैल्यू 4 upon 3 pi r cube rho upon 4 pi epsilon r square. 4 pi से 4 pi कट जाएगा, r square से r square कट जाएगा, एक r बचेगा, 3 नीचे आ जाएगा तो ये आ गया r rho upon 3 epsilon. Therefore E is equal to r rho upon 3 epsilon. Therefore E is directly proportional to r. R is the distance of the point, r is the distance of the point from the center, r is the distance of the point from the center of the solid sphere. Therefore E is directly proportional to r. At the center of the cell, at the center of solid sphere, r is 0. When we put r is equal to 0, therefore E is equal to 0. Therefore electric field at the center of the sphere is 0. At the surface of solid sphere, r is equal to r, capital R. Therefore E will be r rho upon 3 epsilon, which is maximum. As at a point outside the cell, as we have proved in case of previous topic, this will be E dot ds will be Q dash upon epsilon naught. When we solve this, this will be EDS is equal to q dash upon epsilon naught, and E will come outside. E dot ds is equal to q dash upon epsilon naught. Epsilon naught is for outside. This will be E into 4 pi r square is equal to q dash upon epsilon naught. Therefore E will be q dash upon 4 pi epsilon naught r square. Therefore outside the non-conducting charged solid sphere, E is inversely proportional to r square. Therefore variation of electric field intensity with distance from the center of non-conducting charged solid sphere, this will be as E is equal to r rho upon 3 epsilon. E is directly proportional to r inside the cell. Therefore r is the radius of the solid sphere. When r increases, E increases. At r is equal to r, E will be maximum, and outside E is inversely proportional to r square. This will be like this. Therefore variation of electric field intensity with distance from the center of the spherical cell, center of the non-conducting solid sphere, this will be of the type this.